Hi, welcome everyone to the senseFly Academy. I'm Andrea. I'm the training manager of senseFly, and I have with me today Beatrice. So today, topic: how to fly your eBee or your senseFly fixed wing safely in tricky or extreme situations. We're going to talk about tricky start and landing situations, as well as weather influences and how one can trick around those. And then there's some extra about RTK, PPK functionality of eBee+. Launch and start. Often, so many times, I get the question, yeah, how much room do I need to actually take off? How much distance or how much area do I have to have obstacle free? So in the direction of the wind, so we always launch against the wind. I guess that's clear for now. We want to have around 40 meters obstacle free. That's if you leave everything to the default, because after 40 meters, the drone will have reached 20 meters of altitude above takeoff. ATO means above takeoff. So here at this point, you're going to be 20 meters from the ground. And from that point on, you don't know if which way your drone is going to choose to reach the start waypoint. If the start waypoint is right ahead, it might go almost straight to that start waypoint. If the start waypoint is closer toward here, the drone will from here on, it will either turn left or right and then go to the altitude of the start waypoint, which is by default at 75 meters from the ground. So you have to make sure that at this point here, when you have the 20 meters, you don't have any obstacles on the left and the right-hand side that are also 20 meters high or even higher. Okay, if that's not the case, if you do have obstacles that are at this altitude, at 20 meters, it's best to use a so-called directional takeoff. With this, you can just make the drone climb for longer, so until it reached 30 or 40 meters from the ground, to make sure that once it has reached that altitude and then it starts to turn either left or right to go to the start waypoint, it's not going into any obstacles that might be on the left or the right. We'll look at this just in a bit in an example. Landing, also against the wind. So same as on an airport, like on a runway, you're going to start one way and you land basically the same way, always against the wind. Now, how much room or distance do we need obstacle-free? That's 60 meters. So 60 meters from here to that point, and the landing position here, which is basically the center of the home waypoint on the ground. The actual waypoint, the home waypoint, is at 75 meters from the ground, okay, so up in the air. Around the landing position here, we need around 10 to 15 meters obstacle-free, more or less, just in case the drone is overshooting slightly, etc. Now, during the 60 meters here, we should also be pretty obstacle-free, since we are at altitudes already quite close to the ground. I'd say that's around 20 meters, anything between 20 and 3 meters. Before that, so between the 60 meters here to 110 and 160, you can still have obstacles at 13 meters or 26 even. So 160 meters from the landing position, you can still have obstacles that are around 25, 26 meters high, and your drone will be safe at the safe altitude. It's coming in at an angle of 20 degrees, okay? So that's what you have to make sure and pay attention to. Good. So let's look how we can apply this in real flight planning situations. This is the first one, first example. You see it's an industrial area. We have trees in the back here. We have a train over here. We just have this road here that is wide enough and straight enough to give us some room for a start and a landing. And let's assume we don't have any other choice. We're gonna use this. This is about 100 meters measured. You have all of this to handle: trees, power lines, elevation, train, etc. So let's go and try that. You see there's already something activated here. Let's first figure out our start. So our start waypoint here is already placed. You can always do that either manually or through the notification. Right now we didn't get a notification and this was already set here. So our start waypoint, I'm gonna just place it here so that I have it in the direction of where I launch. I'm not gonna launch the other way because I have here the terrain slightly climbing up and all the high trees here, which gonna make it tricky. There's also a little power line here. So better this way, no matter which direction the wind comes from. Of course, I would avoid to fly in this place if I have backwind. Okay, so what I can do, let me just make this smaller. Yep. Now when I connect to a drone, I'll place it now here. Okay, good. You see there is something called directional takeoff. This is activated here in the takeoff settings. You just go into the settings and again into the parameters. It's a bit in, and then here, whether you have this activated or not, gives you that arrow. With this so-called directional takeoff, you can really force your eBee to follow a certain path until it reached a certain altitude and only then go on and reach the start waypoint. Right now we have a warning and we wouldn't be able to take off because our eBee is too far away from the directional takeoff. A directional takeoff always means that you're in a special situation. So setting it up means you have to really be precise. So either bring now your eBee closer, which we're gonna do. We just place it right here, tack, or you bring your directional takeoff to the drone. Works either way, but it's just to make sure that you really use the directional takeoff the way you want it to use. Now, the heading, you can change here. Now we want to follow the road, so it's going to be more like that. And now, right now we have a transition altitude of 30 meters. The default is 20 meters, but we see here that we have a train, which of course has all its power lines up here, etc. We have some industrial buildings which are not too high, but anyhow we want to make sure to avoid those no matter what. So therefore we climb at a safe altitude. So straight climbing until it has reached the 30 meters from the ground and only then turn and go to the start waypoint. The landing, we have a bit of a tricky situation as well here. Home waypoint, okay, we cannot land from the back here, so we're gonna have to land the same way, well, basically against our start direction, which is a very unusual case, but in this place you would have to do it that way. But this is why we're here. We want to talk about some special situations. Okay, so we want to have it to land here, where this is just about enough to avoid the turn here, and you might need someone in this situation to check out a bit the traffic, or maybe even two people. So the drone comes back, home waypoint, then taking off. In this case, we're not giving it any choice. So how we can really make sure that our drone is coming along that road here is by making our approach zone very, very, very small. That just means we're forcing the eBee to take that path no matter where the wind's coming from. If you have strong crosswind, this is of course not a very good choice, and then it might be better to try and find a different place to do your start and landing. But here you can really force it, and that also works normally. Just avoid to do that in strong crosswinds. Otherwise, you risk that your eBee is going to be flipped over by the wind as soon as it doesn't put as much engine anymore. Good. Let's look at the next example. Similar, we have only this little field. It's about 60 meters, so even smaller than we have before. And you see we have all these lights here around these tennis courts. They're probably around 10 meters. We have these trees. We have some elevation changes, etc. Urban area, a bit tricky as well. And this is how fast we can change places these days. Okay, we connect again. Okay, I just assigned now the two the correct start and home waypoint, and again you see I'm using directional takeoff because I want to make sure that the drone is climbing high enough. So again, if you go inside the takeoff parameters, you will find here directional, and here we're climbing until 25 meters to make sure that we're avoiding here all the trees and the lamps and everything. We're going to take off this way. Depending on the wind, we could also do the other way. In this case, that doesn't matter so much. And then the landing, we just set up so we actually land here at the very end. So this is a bit too far here. Now I'm changing the start. 1 second there. Okay, no, so that's correct. So the home waypoint, so the landing position is here basically at the end of the field because that's the 60 meters that we need obstacle free. Before we have though these trees here. Now in eMotion we have the measuring tool. So from here to here, sorry. Right. We have around 100 meters. So we said before at 110 meters, the obstacles can still be around 13 meters. So that would work a bit aroundish for those trees. So we will be able to pass those trees. If you can or want to, you can watch out for a gap between the trees and try to align your approach zone with that gap so that you have a bit more room to the ground in case your drone comes in a bit lower than normal. You could do the same the other way around. But here is just you start on one end of the field and you land on the other one. That's what I would do here. Good. Third example, high altitude. So let's say we are somewhere at 3,400 meters. Traffic, that's just in case you're on a mine site, which, yeah, you just have to make sure you're in contact with the management and they don't start to come up with the big machines while you're there in place. And the third factor that might be quite tricky in these kind of places is the wind. So potentially you have to adapt your flight time to a day of the time where it's less windy, or just to a season where it's not as windy. Can be quite challenging to find a good way there. So what we do here, let me just disconnect that way. And we go here. It's not quite the same place, but also pretty high. So what our main problem is if we are at high altitudes, is that the air pressure is lower. Therefore, the uplift that we experience, or that an airplane experiences, is much less. So you will have a longer distance until the drone actually is lifting up from the ground, or reaching a certain altitude, or getting to those 20 meters. It will, before we said that we need a distance of 40 meters until the drone is at 20 meters. Now at this altitude, it can be more like 60 or 80 meters until the drone is actually at the 20 meters. What you can do is, in those cases, you just throw it in the open space. You throw it here over into the empty space, and then if the drone sinks a bit down, it will just gain a bit more speed, and then use that speed to nicely recover and climb back up to the start waypoint. You see here the start waypoint. I have to turn off the measuring tool. The start waypoint is here, so somewhere around this here. Assuming that we launch from somewhere here, it will nicely go over and come back, climb up here. So that's the main. For the landings, it's usually not a big deal, except for that in mountainous situations, it's often tricky to find a place where you don't have as many rocks, and yeah, it's more a matter of finding a good spot on the ground. Good. So next situation is landing at a different altitude than where you take off. So assuming that we take off here and we want to map here the whole slope and then arrive down here, or plan our landing down here, we cannot use above takeoff altitudes anymore, at least not for the landing, because above takeoff is up here. If we take off here, this is going to be our takeoff altitude. So our landing will be planned for this altitude. What we have to do is we have to use the elevation data, or AMSL. So above mean sea level altitudes, and specify them correctly in the landing parameters. Let's say we're going to fly down this slope and want to land here on this flatter area. I'll just increase the working area parameters in order. Working area parameters, you can adjust them either manually or based on the drone's position. Then, are we high enough? No, to make this a bit higher, so good. So this is for the planning mainly. Okay, so our home waypoint, let's just move it down here. I create a new one. Linear. Okay, always choose linear landing. Circular landings, they take way too much room, and it will circle down in a radius of 30 meters. You may not even know where it's coming down or landing, etc. Good. So we have, so far it looks all not so bad. We have our start up here, our landing down here. Basically, it's all good. But now let's connect. Position the drone a bit better. Voila. Okay. Just have to make sure I assign the correct start. Yep. and home waypoint. Okay. So now watch what's happening to the home waypoint once I assign it. Tick. Good. So our landing position that is supposed to be on the ground is now up here. We can still adjust here our approach zone, but actually it's going to be quite an airy landing. So let's try this, just because we can in the simulator. So the drone's climbing to the 75 meters. Now we tell it to go land. We're now not doing a mission in between. There you go. The drone is at 75 meters ATO, which is correct, right? This is the default setting for our start and home waypoints. It's still ATO, but now it's expecting to be on the ground. It's realizing it's not on the ground, and it's actually gonna keep going and going. And then it goes into a circular landing, trying to find the ground somewhere. You may not know where it's gonna end up, etc. So that might not end well at all. So if we set up a situation like this, we have to make sure that our landing or our home waypoint is not set to be ATO, above takeoff, because above takeoff is much higher. We want to be above elevation data if you trust it, or if you know the exact altitudes, you can also use above mean sea level. Now we're going to go for AED. And you see that actually our home altitude at the moment is 380 meters from the ground, and the landing position is 305 meters from the ground, or above elevation data. So let's correct this to 75 meters. That would be the altitude of the home waypoint, and this one to 0. There we go. If we now assign this, and we assign it was this one. Okay. So now if we take off, now I didn't place my drone right. There we go. Go maybe a bit faster. Now it will keep the altitude, and once it has reached the position of the home waypoint and X and Y, it will just circle down to reach the 75 meters from the ground and then do a proper landing as we're used to. Good. Weather. Now on the northern hemisphere, it's getting hotter, and yeah, around 25 degrees or even 30 degrees. If we place our drone on the ground, the sun is shining on top of it, the battery is in. It can happen that the autopilot overheats. Within 10 minutes, 15 minutes, it can happen. So always have an eye on this, on the autopilot temperature under instruments. So 40 degrees is about normal. The critical temperature is 75 degrees. 75 degrees, this green changes to yellow, and a bit later then it goes into red. And then you risk to break your autopilot. So make sure that once you place your drone on the ground and you plug the battery, move a bit quick. Upload the mission, get your start and home sorted out, and launch. If it's going to take you longer to sort out your mission, try to do start and home first, and then just launch the eBee without the mission assigned. go back to your laptop and design your mission and assign it. As long as you have the communication link, you can change and upload or reassign anything during the drone is in air. Having the drone in the air just helps the autopilot to cool down, or the airflow, make sure that the temperature is not increasing much more. If you realize, though, if it's sort of too late and this is already yellow and you're still not ready to launch it, take out the battery, move the drone into the shadow or into the air-conditioned car or a cool place where the autopilot can cool down. And then you get ready, you wait a bit longer, and then you go for your flight. Cold. So that's more now for the southern hemisphere. Keep the batteries warm, so keep them close to your body, for example, which always has a certain temperature, or then organize a battery warmer, which you can usually get at hardware stores. If your batteries are cold, expect the flight time to be slightly reduced, which is, it's not a big deal, but don't maybe plan the biggest mission in cold temperatures. Wind. If we have strong wind, eBee flies until 12 meters per second. That's 43 kilometers per hour of wind. Flight time might be slightly reduced. If you have this kind of situation, I would say even after 8-9 meters per second of wind, your mission output or the result that you get might not be as great, since the drone is gonna fly. It will always have to fight the wind. If you fly crosswinds, the drone's heading, so its position in air will be more pointing against the wind, but actually flying sort of sideways, which is also called crabbing. And therefore, of course, your picture, what the picture is covered, or the layout of the picture, will also be rotated, and therefore you have less overlap between your images. Means you have to increase the overlap in your mission settings. Maybe better to wait for less wind if you can. The drone will not fall out of the sky, but it will just be a messy data set where probably a lot of images cannot be calibrated if the wind is too strong. If you're going into places that where it's hardly never any like wind free or not as much wind, you can just estimate the mission wind. So simulate some flights with more wind. You just increase the speed here. You can even give it the orientation of the wind, which in some places is always about the same. It can be seasonal, it can be based on the time of the day, etc. So you can already adjust and try how this influences your mission, your battery, because with a lot of wind, your battery is going to be used up much faster as well. You always have the option to plan your mapping blocks crosswinds, which is 90 degrees towards the wind direction, which is not always practical. So try it out in the simulator, see how it takes influence on your mission. Sometimes it's better to have it at 45 degrees against the wind, like crosswind. So your flight lines are at 45 degrees to the actual wind direction. That's giving you usually a better result than 90 degrees because the drone doesn't have to turn as much. Good, so that's it for tricky situations and flying with in difficult situations. And we move on to RTK PPK Extra, where it's mainly if you have the setup with a base station on an unknown point. So you're streaming your RTK, your correction signal, from a base station that is placed on an unknown point. Now, when you're are back in the office and you need to now find out or correct the position of this base station, for which again you need a course network or some service from the state usually, or for some provider to correct your positions, your station's position. So getting from unknown to known point is also called PPP, precise point positioning, RTX post-processing. Those are the terms used for this kind of process. Actually, there are several services that are provided worldwide, for example, by Trimble. Trimble provides a service called Centerpoint RTX, where you can just upload your estimated position and you get a correction for it. Or Auspos would be another one. It's an Australian service. And we get the accuracy that you get for the position of the base station is 10 to 40 centimeters. Of course, there are better ways. If you do have an option to get a higher accuracy, that might be a better choice. But if you are in locations where it's very hard to get anything else, this is already very good. How it works is that you have to register. Most of those services even are free or free for a certain amount of data. You select your coordinate system. You upload the observation file from your station. And usually the longer the occupation time that you have, the better or the more accurate the result. And then you will receive a PDF file on your email that gives you the corrected position, which you can then enter in eMotion. And with this, I thank you for joining today's senseFly Academy session, and hopefully see you next time. Thank you. Bye.